Hey guys, this is Wednesday's DMR. So I've gotten a couple questions from some of you, and I agree that Wednesday's DMR is a little challenging. I was working on number one before I started the video, and I did not find an answer that was an actual choice on the paper. I will explain what I did, and then you guys can tell me whether you got something different. So please feel free to comment and share your thoughts. So Wednesday, it says Joe scored 384 points on his video game. So I have that here. And it says his friend Jeff scored 4 times as much as Joe. So I put in Joe and I multiplied it by 4 and I got 1,536. And then it says Jim scored twice as much as Joe and Jeff together. So I added Joe and Jeff together and I times it by 2 because it says twice as much. Okay, and then I got this number, 3,840. And then it says how many points did they score all together? So what I did is I took their total points and added them all up. And when I did that, let's see. I got 5,760. And that is not an answer choice on number one. So I'm sticking with 5,760 points altogether. If you have a counter argument to me, please share it. You know I welcome a good argument, but I could not figure out any other way to do it, okay? So that's my thinking. Hopefully that helped you. Number 2, it says which numbers below are considered prime. So I just highlighted the prime ones. 13 can only be made with 1 times 13, 47, and 71. If you cannot remember, you can either use your calculator and try your divisibility rules like 91 divided by 2, 91 divided by 3. And if you get a whole number as an answer, it's composite. Okay? If none of them work, it's prime. Let's look at number 3. So number 3 is kind of new for you guys. Number 3 is an area and perimeter. So every day I'm going over how to find area and perimeter, okay? Kevin, I know you had a question about this one. This is for you, okay? So area versus perimeter. Area is the amount of space inside the shape. So for example, there are 4 cubes that make up that one. Okay, area and perimeter of the second shape. 4 cubes that make up that one. Area and perimeter of the third shape. So area would be the space in between. Again, made of 4 cubes. Okay, now I'm going to count the perimeter or the rim. I want you to look at the word rim. Okay, think about the rim on a basketball hoop. It goes around the edge. So we're going to count the sides on the edge. Okay, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Look at my black hashes. Where each box has a side, I just put a dash and I count that as 1. So for example, 1, 2, 3, 4, 5, 6, 7, 8. Okay, that shape has a perimeter of 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, remember when you're coming around here, make sure you get this corner right here. Okay, make sure you get this corner as well. So then it says circle the 2 shapes that have the same perimeter and the same area. So it looks like shape number 1 and shape number 3 have the same area and perimeter. Here they are, those 2 shapes, okay? Hope that helped. All right, number 4. So I did number 4 before I got on the video. I'm going to try to show you what I did. So it says Joe wants to walk 436 miles in 7 days. And then it says, how many miles will he walk each day? So what you're doing is you're taking the 436 miles and you're dividing it across 7 days. When I did it on the calculator, I got 62 point, and then as a really long decimal, 28571. So I just rounded it, not even rounded it, I just cut it off at the hundredths place. And I'm going to show you what I mean by that. So I wrote 436 divided by 7. 7 couldn't go into 4, but it could go into 43 6 times. So 6 times 7 is 42, so I subtracted. And I got 1. I brought down the 6. And then I said 7 can go into 16 2 times. 2 times 7 is 14, so I subtracted and I got 2. Instead of stopping there, what I did is I put a decimal and put some zeros, and I moved my decimal up, and then I brought down a 0 and made it 20, and then I just kept going. Can 7 go into 20? Yes, 2 times. 20 minus 14 is 6. Then I brought down another 0, and you could honestly go on forever and ever and ever. There is an infinite number of zeros that you could use and just keep going and going and going, but I just stopped when I got to the hundredths place. A teacher in the future, I'm assuming, would say, give your answer to the nearest thousandths. Okay, so I'm saying you can stop at the hundredths if you want. Okay, number 5 was also a little tricky, and I had a question from Sarah Lasser on this one because the bars are not perfect on the graph. So let me read the graph, and then we'll answer it together. It says, the chart below shows how many boys and girls are in each grade. Which grade, so we're going to answer with either grade 1, 2, 3, or 4, has the greatest difference in the number of boys versus girls? Difference means we are going to use subtraction between the boys and the girls to see which one has the greatest difference. So we're looking at when we subtract, what's the largest difference? So for grade 1 was pretty simple because it looked like, yeah, it does look the colors look the same. We're just going to assume 25. Let's say the dark is the girl and the light is the boys. So 25 girls, 30 boys. 30 minus 25 is a difference of 5. Grade level number 2. This is where it gets tricky because this is definitely, I would say, halfway, but then this bar, I just rounded it to 22. It was really hard for me to see, so I got a difference of 7. Again, this was right on the 20, but this looked a little bit greater than half for grade 3, so I just put an 8. So 28 minus 20 is a difference of 8. So if your answer doesn't perfectly match Miss Connolly's, don't freak out. It's okay. Then again, this looked like about 22. It looked like it matched over here. And then I said this was about halfway or 35. So that difference was 7. So let's look at the grade level. What grade level, grade 1, 2, 3, or 4, had the greatest difference? Grade 3 has the greatest difference based on my reading of the graph. If we were in class, I would have given you a better graph that was more specific. Maybe the lines would have been broken down over here so you could see. Sorry, this day was not perfect. Hopefully that helped you, Sarah. I know the colors, again, when we copied them, weren't perfect. Not a big deal. So hopefully that helped you. And Kevin, I hope the area and perimeter problem was a little bit more clear. Thank you guys for asking questions. I'm always here to help, okay? Love you guys, and we'll do Thursday tomorrow.